Hello everyone, and welcome to VisualCAMc for Onshape. In this video, we're going to be taking a look at our Quick Start Guide for VisualCAMc for Onshape. And I have the Quick Start Guide part displayed, and we'll take a quick look at the VisualCAMc display. So when you load VisualCAMc, you'll see the VisualCAMc tab down here on your Onshape tab menu. This would be the Onshape part, and you'll have the VisualCAMc part. And then also you will see, if you want to review this Quick Start Guide in a document form, there's also a tab here to display the Quick Start document. So let's go ahead and get started. VisualCAMc, this display, is divided into three main areas. At the top, you have your main toolbar where all of the menus are available to machine a part. And on the right, we have the part display window where your part is shown and any toolpaths that you create are shown on the part here. This display also has a heads-up toolbar at the top where you can manipulate your display of your model for different views, zooming, etc. Also, in the top left corner of the display window, you have a series of icons that you can use to turn on and off various elements of the VisualCAM display. For example, you can turn the stock on and off, or the part. If the part's off, you can see the machine coordinate system and the world coordinate system triads. Those can be turned on and off. And then also on the left side of the display is the machining browser. Now this is where a lot of your main activity will be taking place as you create toolpaths and simulate them and post-process them. It's divided into two tabs, the Machining Job tab and the Tools tab. The Machining Job tab is where your machining elements are listed for this particular part. The Tools tab is where you can create and list your cutting tools that you use for the current part. So let's go ahead and get started. Our strategy for machining this particular part, we're going to use a series of 2.5 axis toolpath operations. Now this part, as you can see, is a prismatic part. It's got straight walls, it's flat, it's got holes in it. So we don't need 3-axis operations to machine this. We're going to use 2.5 axis facing to machine the top. And then we're going to use 2.5 axis profiling to machine the perimeter. And then we'll also use drilling to machine some of these holes. So let's go ahead and get started. Your approach to machining any part in VisualCAMc is to follow the main toolbar from left to right. So we're going to start with the machine. By default, the machine coordinate system is aligned with the world coordinate system in Onshape. So by default, we don't really have to change this right now, but in the future, you can use this to manipulate your machine coordinate system to the orientation that you want to machine for your part. Then also, moving from left to right, we'll set our post processor. And VisualCAMc supports over 300 pre-configured post processors for all of the popular controllers on the market today. So we'll go ahead and select our post. We're going to use the Haas controller, and we'll pick Save. And as you can see, the post is now listed under the machining job. Next, we're going to go ahead and set up our stock. So we'll pick the stock button. And as you notice, when you run different commands, the dialogues will appear in the under the machining job tab. So this tab, the machining browser, does a lot of different functions in VisualCAMc. So let's go ahead and set up our stock. By default, the size of your part is listed here in X, Y, and Z. Now the stock that we're going to use is 1.5 inches by 1.5 inches by 3/16 inch thick. So we're going to go ahead and enter offset values to offset the part in X, Y, and Z to achieve our stock dimensions. So for X, we'll enter 0.0106. That will get us up to 1.5 inches. We'll do the same for Y. And then for Z, to get up to 3/16, we're going to enter 0.03, which get up to 3/16 inch thick stock. So we'll go ahead and pick Save, and you'll see that our box stock is listed on the machining job. Now, if you don't see the stock on your screen, as I mentioned, you can turn these toggles on and off. So now you can see the stock. That's the stock box without the part displayed. So now let's talk a little bit about setup 1. By default, when you open a part in VisualCAMc, you have a setup already defined, and again, it is aligned with the world coordinate system in Onshape. So your setup defines your machine coordinate system along with the machine definition, but you can move your setup by using the work zeros. For instance, what we're going to do is we're going to zero out our machine on the top left corner of our stock. So let's go ahead and select work 0. In this dialog, we're going to set it to the work 0 type to the stock box, and you'll see that when you set it to stock box, your machine coordinate system triad jumps from where your world coordinate system is over to one of the corners of your stock box by default. So we're going to move it to the highest Z, which means the top of our stock, and we're going to set it to the southwest corner. So this is the corner that we're going to home our machine out on. So we'll go ahead and pick Save, and you'll see that we have the work 0 listed under setup 1. When you create operations, it's always a good practice to select your work 0 to make sure it's selected before you create an operation, but that way when you save the operation, it'll be located under the work 0. Because it will be under the work 0, all of the coordinates for the tool motions will be measured from this work 0 location. So let's go ahead and create our first tool path. We're going to go ahead and select 2.5 axis. We're going to do a facing operation. Over here on the left, the toolpath dialogs are divided into different tabbed areas for selecting the different parameters to define your toolpath. So to start off, we're going to go ahead and name our operation. We'll call it top face. And then also, we'll go ahead and pick the Select Tool tab. Now, creating cutting tools in VisualCAMc, you can do it directly from the operation, or you can do it from the Tools tab. So let's go ahead and do it from the Tools tab this time, and then we'll do it from the machining operation for the next operation. Under the Tools tab, we have a toolbar where we can create cutting tools and list them in different orders. Let's go ahead and create one. Pick the Create Tool icon. It'll display the Create Tool dialog. Located at the top of the dialog, you have the different tool types that are supported by VisualCAMc. For the facing operation, since it's a facing, we can pretty much use any one of these tool types. Well, let's go ahead and create a facing tool since we're doing a facing operation. And we'll go ahead and call it Face Mill -1.0 diameter. We'll create a 1-inch diameter face mill. For the tool holder diameter, we'll leave that set to 1. The tool holder length we'll set to 1.5. The shank diameter, we'll leave that set to 0.5. For the tool length, we'll set that to 2. And for the shoulder length, we'll set that to 1.5. And for the flute length, which is the actual cutting area of the facing tool, we'll set that to 0.375. And for the tool diameter, that'll be 1.0. And the shoulder diameter, we'll leave that to 0.5. After you set your dimensions for the tool, you can go ahead and set some properties for the tool. So we're going to use a high-speed steel tool. Number of flutes will be 2. The tool number, we'll leave that set to 1. Tool number, adjust register, cut com register, those should all be the same as your tool number. And axial offset we'll set to 0. Coolant, we'll go ahead and use a flood. And for the comments, we'll go ahead and say, well, this is my first tool. And that'll be commented out in your G-code whenever you post it. So let's go ahead and pick save. So now we have a face mill listed. Let's go back over to the machining job, and we see our face mill listed here. And as you can see, a pop-up dialog tells you a little bit about the tool as you move the mouse over it. So now that we have a face mill created, let's go ahead and set the feeds and speeds. We'll accept these default values for now. For the clearance plane, this is the location where the tool moves to begin its approach motion to cut the part. Now, it has 2 tabs. It has a plane definition, so you can use these different methods for locating the clearance plane. And when this dialog is displayed, you can see that the clearance plane is displayed on the screen. So for this part, we'll go ahead and leave it set to automatic, and VisualCAMc will automatically determine a face safe distance to locate the clearance plane. For the cut transfer method, this is the method at which the tool will use when it transfers from one cutting location to another. So we're going to go ahead and set that to clearance plane. Now for the cutting parameters, for the facing operation, we'll go ahead and set the tolerance to 0.001. We'll set the stock to 0. And for the location of cut geometry, this is decided by what geometry you select to drive your machining toolpath. So let's go ahead and select you can select your geometry anytime this dialog is displayed before you generate the toolpath. You have, in all 2-axis operations, you have to select some geometry. So in VisualCAMc, the mouse buttons help you out in selecting. If you select using the right mouse button, it'll automatically chain select a perimeter chain of edges for you. If you just wanted to select one edge, you can do them by a left mouse button and select the edges around. If you want to go ahead and chain from there, you can go ahead and select the right mouse button. So we've got our this is the boundary that we're going to use for our facing operation. So everything within this boundary will be included in the operation. So to get back over to the location of cut geometry, where's the geometry that we selected? So in our cut, the location of this geometry, we want it to be at the bottom of the cut. So we want the facing operation, the tool to come down and cut to this Z level of this geometry, which is the top face of our part. For the cut type, this is the pattern that the tool uses to cut the part. You could have it linear or offsets. We're going to use the offset cut type. And for the cut direction, we'll set it to mixed. For the total cut depth, we're not going to be cutting any deeper than our control geometry. So this will be set to 0. So we're going to make one pass right at this Z level at the top of our part. So the depth of each level obviously will be 0 since we only have a 0 depth. And for the step over distance, we'll set that to 0.25. After you finish your cut parameters, you have an entry and exit tab. Now this will determine how the tool approaches the part for cutting and how it departs and retracts from the part. So for the entry, we're going to go ahead and use a geometric entry type, and we'll set it to radial, and we'll have a 1/4 inch radial entry. For the exit, we'll go ahead and do geometric. Well, let's go ahead and do none for exit. Let's just retract straight up rather than putting any additional tool marks on the part. So now that we have our parameter set, we can go ahead and generate the toolpath. So here we go. We have a facing toolpath displayed. Here is our plunge motion, our approach, and our engagement. And you'll see that they're color coded. So the plunge is in yellow, engagement it will be in green, and the approach will be in green, the engage motion be in magenta, and then your actual cut motion will be in light blue or cyan. So there's our toolpath. Let's go ahead and create a cut model of this toolpath. Now, currently we have the stock defined and we have a toolpath defined. So let's go ahead and create a cut model from this toolpath. So it's going to update the stock to display the in-process state of the stock. So to do that, just right-click on your operation and we'll pick Create Cut Model. Okay, so here we can see we have the stock was cut down to our top face of the part, and you can see that here. This was our work 0 at the top of our stock, and it was cut down to the top face of the part. And you can turn the stock on and off, as I've mentioned, using these toggles at the top. Okay, so now we got a toolpath, we have a cut model. Let's go ahead and do a toolpath simulation. Again, just right-click on the top face operation and pick Simulate. This displays the simulation dialog on the left, and as you can see, you have the the motion type listed here, and it goes through each of the motion types used in this toolpath, and it tells you the values on the right. And there's controls at the top. Just like a recorder, you can do a play, pause, stop, and exit the simulation. Let's go ahead and run it. So we see the tool making our engagement motion, and now it's doing our cut motion. As you can see, each motion that is simulated is displayed in the simulation dialog. There we go. There's our toolpath simulation. And if you don't want to wait for the entire simulation, you don't have to wait for the entire simulation to complete. Once it's started, you can do a pause and you can do a stop, and you can start again, or you can stop and exit. Okay, so we got a toolpath. We've got it cut model created. We've got it the toolpath simulated. We verified that it looks good. So let's go ahead and create our next operation, and this will be a 2.5 axis profiling to cut the outer perimeter of this part. So with our top face operation selected, let's go ahead and go up to the 2.5 axis menu. We'll pick profiling. Now you'll see that the edges that were selected for the previous operation are already selected, so we don't need those. Happen to be the same edges we want to use to do our profiling operation, so we don't have to reselect any geometry. Let's name this part outer perimeter, and for a tool, we don't have a tool. We don't want to use a face mill, obviously. Let's go ahead and create a flat end mill. We'll go ahead and select the Create Tool icon. From the Create Tool dialog, we'll select Flat Mill. And for the name, let's go ahead and call this Flat Mill 0.125 diameter. So we're going to create a 1/8 inch diameter flat end mill. So for the holder diameter, holder length, shank diameter, we'll set that to 0.125. For the tool length, we'll go ahead and set that to 2. For the shoulder length, we'll go ahead and set that to 1.5. And for the flute length, we'll set that to 1. and for the tool diameter, the 0.125. Now it's a good idea to always have your tool diameter and your shank diameter the same. Even if your tool has a larger shank diameter, it's a good idea to make these the same, because if your flute length and your shank diameter and your tool diameter differ, if these two differ, it could show up in your tool path. So it's good to have those two the same diameter. So for the properties, we'll go ahead and set it to a high-speed steel. Automatically uses the next tool number, and everything else looks good. We don't really need any comments here for this tool. So let's go ahead and pick save. So now we have another tool added to our tool list. We'll select flat mill for this operation. Feeds and speeds, we'll leave these set to the default parameters. Clearance plane, we'll leave that set. Now for parameters. For our profiling operation, we want to have a nice cutting motion, one motion around the exterior of the part. If you wanted to, you could start away from the perimeter and work your way in successive cut motions. You can do that, but for this part, we're just going to have one motion at different levels. So for the tolerance, we'll leave that set to 1,000th. The stock, we'll have it set to 0. Now, if you set the stock to a higher value than 0, it would back off of the sidewalls by the stock amount. In other words, you could do a roughing operation, leave some stock, and then come back and do a finishing profiling operation by setting the stock to 0. So there's a lot of different ways you can machine this. So for this guide, we'll go ahead and set that to 0. Now, where's our cut geometry at? So we want to cut from here down to the bottom of the part, obviously. So our location of cut geometry for this operation would be at the top. So for the cut direction, we'll leave it set to mix. For the width of cut, we want to make one pass at different levels, so this will be 0. If you wanted to offset and start outside the part, you would set this to a higher value. Again, for the step per cut, these two go together, so that'll be 0. The total cut depth. Now, I happen to know that the depth of this cut is 0.157. So it's going to start here, and it's going to go down 0.157 for our total depth. And for the depth of each level, we'll set it to 0.05. So it'll be 50 thousandths each cut level. So also, since we have a closed curve, we'll check this box and we'll select the outside of the curve. So it's going to cut on the outside. It's going to start at our geometry level, and it's going to cut down 100.157, and it's going to cut at levels of 50 thousandths. Now, let's go ahead and select our entry and exit. Now in profiling, it's always good to use a ramp entry motion, so you got a gradual ramp in and start cutting your part. You could have a radial entry, but for this part I want to do a ramp entry. So we'll select this a long path, and for the height of the ramp we'll set the 0.15. So it'll start 0.15 above your first cut point. And for the angle, let's set it to 5 degrees. And for the exit, we'll go ahead and do a geometric exit and do a radial 1/4 inch radius departure from the part. So let's go ahead and generate the toolpath. So this, as you can see, let's go into the front view here. You can see our plunge down to our ramp starting point, which is 1.15 above our part, and a nice 5-degree ramp entry that it's going to actually ramp right around the part. So it's going to start here, and it's going to go 5 degrees and ramp all the way around over to our start point over here where it begins cutting. So let's go ahead and do a simulation of this cut now that we got it made. Right click on the operation and we'll pick simulate and pick play. And so here we go. We've got our 1/8 inch end mill. It started the nice ramping motion. Let's go ahead and pause that, stop and play that again so you can see the nice ramp entry motion. Let's go ahead and go to a front view and run the simulation. So there's our nice ramp entry motion. where it goes into our start point over here and starts our first cut level. And then it'll step down to our next level. And because we have a mixed cut direction, it comes back the other way. And there's our departure and our retract. Okay, so let's go ahead and create a cut model of the profiling operation. Just right click on the operation and pick create cut model. So here we go. We see that our cut model is, let's turn the part off. So here is our cut model. You can see that we cut all the way around the part. It's a nice clean cut all the way around there. And let's go turn the part back on. Now that we have a top face operation, there's our cut model for the top face. There's our cut model for the profiling operation. Now let's go ahead and drill some of these holes. Let's drill these 4 holes on the inside pattern. So let's go ahead and we'll go to the holes menu and pick drilling. And for the name, let's go ahead and call this drill 0.157 diameter holes. Okay. For a tool, obviously we don't have a drilling tool created yet, so let's go ahead and create one. And as you can see, you don't have all these different tools to select from. When you create a tool from the toolpath dialog, it knows that only certain tool types are supported by that particular operation. So for drilling, you have your drill tool and your center drill tool. So we're going to create a drill tool, and we're going to name it drill 0.157 diameter, and holder diameter be the same, holder length to be the same, the shank diameter be 0.157, the tool length, we'll set that to 2, and the shoulder length 1.5, and the flute length 1, tool diameter 0.157, same as the shank diameter, and the tip angle is 120. And for the tool material, we'll select high-speed steel. Tool number will be number 3. And let's go ahead and save this tool. So now we have a drill tool that we've created, and we'll go ahead and select it for our drilling operation. Now, since our geometry is different, let's go ahead and we'll just pick anywhere outside of the part to deselect our geometry. So then now we want to do a left click and select the 4 holes in the middle of the part. So we got the 4 holes selected. For the feeds and speeds, now since this is drilling operation, we want to slow this down quite a bit. So let's slow it down to say 190 RPMs. The cut feed, make that say 10, make that 10, and make that 10. So for the clearance plane, we'll leave that set to the default value. Now for the parameters, for the drill depth, now the drill depth is going to be measured from where you say your selected geometry is. So the geometry I selected is at the top of the hole. So we're going to set this to at top. And the drill depth is going to be 0.157. That's the depth of our 3/8 inch stock. So we're going to set the dwell to say 5 seconds, and then we'll set the approach distance to 0.15. And another cool feature is we're going to pick this box to add the tooltip to the drill depth. So it's going to clear the material by the amount of the tooltip so that you get a nice clear through hole. So let's go ahead and generate that. So here's our drilling toolpath. As you can see, it extends past the bottom of the part. Let's go ahead and change this to the front view so you can see that. It extends back past the bottom of the part by the depth of the tool tip. Let's go ahead and we'll go ahead and do our cut model. We've got our top face operation. We've got our outer perimeter operation. We've got our drilling operation. Now let's go ahead and post some G-code. Now you can post one operation at a time by right-clicking and select post, or you can post the entire setup, which will include all of the operations. Let's go ahead and post the entire setup. Right-click on the setup, pick post-process, and what's happening here is it's creating your G-code file, and by default it uses the part file name and the setup name. If you had selected an operation, it would append the operation name, so it'll add those two together to create the file name. And by default the file name is .nc, and when it displays in Notepad you can save this out. If your controller needs a different file extension, you can change the file extension locally on your machine. So let's go ahead and we'll just open it directly and we'll pick OK. So here's our G-code for our three operations. Here is our setup, our work 0. This is our first operation, top face. Here's the tool comment that we put in, and it begins the tool motions for the top facing operation, and then it'll go through the profiling and also the drilling. Well, that's it for now. Stay tuned for more videos on VisualCAMc for Onshape.